Hello folks, welcome to Cyberblocks. Today in this video, we are going to learn what is a block in the blockchain. To understand what is a block in the blockchain, first we need to have a basic understanding of what is a blockchain. To know what is a blockchain, just go back to the channel and I have uploaded. Just see the previous video to this one. You will be getting the basic knowledge of what is a blockchain. And the video also has the title of what is blockchain and all. So let's get started with our this video. In this video we'll see what is a block in the blockchain. So to understand that, let me give you a brief understanding of what is blockchain means. Take an example of our traditional database. This is a database and we'll compare it with our blockchain. Blockchain is a series of blocks which are connected to each other using cryptographic hash. It is a digital ledger. It is a digital ledger. So let's see what we can do in our traditional databases. In traditional databases, we store the data in various form. Like in relational databases, we store the data in tables in relational databases, and we store the data in form of objects in non-relational databases, non-RD, which are this non-relation this can relational databases also can be called as SQL, and these non-relational databases are also called as NoSQL. The data which are stored in our traditional databases are mutable. What what do I mean by mutable? Mutable means once the data is written in the tables or object, they can be changed, updated, change or updated, both are same, or even can be deleted. The the data in the blockchain is stored in blocks, and whatever the data which is there in these blocks are immutable, and the data can be only viewed. It cannot be changed or updated. So this is a main difference between a blockchain and a traditional databases. In tradition, the main difference is the data in the traditional databases are mutable and data in the blockchain are immutable. Means they can in the traditional databases they can be changed or updated and even can be deleted. When it comes to blockchain, they can be neither changed or neither updated. They are a permanent record of data. It is a permanent record. If you think a book as a blockchain, uh, just forgive my drawing skills, those are not up to the mark. So if you think this is a book and this is our blockchain, then in the pages which are in here in the book, the pages are equivalent to the blocks. Means the data, each page is consist of some data of this particular book. So in this, each block consists of some data of this blockchain. You can compare it like this. The data which is stored in these blocks are specifically transactions. We can say they are transactions. In Bitcoin blockchain, Bitcoin blockchain, these are nothing but the transaction between sender and receiver. It will store the information of the sender, receiver, and the amount which is being sent. And these blocks, whatever the blocks are there, they can hold different types of data, like different variations of the data, uh, depending on the type of blockchain or what blockchain you are using. So let us see what is the structure of the block. Let me draw you a overview of structure of the block. So this is typically a block structure. It is divided into two parts, mainly the block header and block in the body. Block header will consist of many fields. There will be plenty of fields. We'll see what are those fields. And one of the most important field is previous block hash, and there will be some other fields in just we'll look into what are those. So this is typically a structure of the block, how it might look. Let us see what are the other fields which are present in this block header. Let's first talk about what is a previous hash. If you observe, our blockchain consists of series of blocks which are connected to each other. And in my previous video I've explained that each block has a hash of its own. Hash of its own. So to link these hashes, like if you want to let's number them 1, 2, 3, 4, 5, 6. So this block number one consists of hash of its own, and this number two also consists of hash of its own, and number three and so on. But to link them, like to link block 1 and block 2, then block 2 and block 3, then block 3 and 4 with each other, there is another part which is previous hash. So this block 2, whatever this block 2 is there, it will store the hash, its own hash. Along with that, it will store its own hash. Along with that, it will store the previous hash as well, and this previous hash is the hash of its previous block. What I mean to say is this block, if you take an example of this block number 2, it will store the hash of its own and the hash of its previous block, that is number 1 as well. Now let us see what is a nonce. The abbreviation of nonce is number used only once. Nonce is a number which is usually used by the miners or find by the miners to successfully mine a block. Means miner attempts to find a block, to find a nonce which satisfy the current consensus of that chain. Consensus is nothing but, you can for now you can say consensus is a some kind of condition that has to be met to mine successfully mine a block. I will make a dedicated video on this for on consensus, what is a consensus and what are the different types of it, and we'll make a different separate video for that. For now you can just think of it as it is a condition that has to be met to successfully mine a block, and miners attempt to find this value nonce to uh, mine that block. Our next topic is timestamp. Timestamp is nothing but it is the time at which that particular block was mined. Mined in the sense the block was added to the blockchain. It stores the time when that block was added to the blockchain, and it this time is usually recorded in Unix time systems. Our next topic is difficulty. Difficulty is nothing but how complex or hard it is to mine a block. It is how complex or hard to mine a block. In the previous video demo of blockchain, I have explained how hashes are generated and everything related to hash in a blockchain. I'll provide a link in the description. You can just visit the thing if you are interested to know how hashes are generated and all those four leading zeros topics and all that will then you will be finding it clear to how it is complex. The complexity of the generating hash increases as the four leading zeros increases. Whatever this difficulty is there na, this difficulty it increases as the four leading zeros. The leading, not four leading zeros, whatever hash we are getting out of the data, the previously the leading characters whatever they are, if they are more zeros, if these zeros are increasing, then the difficulty also increases, as our hash consists of 64 characters and we are fixing first four characters to be zeros by default. So we only left with 60 characters to generate a hash. So we like this, we are increasing the complexity of the block to be mined by increasing the number of leading zeros. Let me tell you how it is complex as well. For example, for a simple data, you are passing to SHA-256, oh sorry, 256, and it is giving a hash, and this entire process is taking 1 second. So if you are reserving first four characters as a four leading zeros, then this the simple data and we are you are passing that data to let that simple data the data be same one, and we are passing to SHA-256, SHA-256, and this time we are restricting it to generate the hash, and that hash should contains four leading zeros. Then this time it will take at least 2 to 3 seconds. This is just an estimation to explain you how the complexity increases. This is not the exact time. So it will take around 2 to 3 seconds to generate this hash. So we can state that as the number of leading zeros increases, the difficulty of the chain also increases. Now let us see what is a Merkle root hash. I'll call MRH a short form, Merkle root hash. Before understanding what is a Merkle root hash, let us understand how the hashes are formed. Like you have a piece of data and you will provide the data to SHA-256, and that will provide you with the hash of 264 bits. Okay, so this is how a hash is formed. Now if you take an example of transactions, there is a say there is a transaction which happened on the blockchain, and then this transaction will be passed to SHA-256, and SHA-256 give us a hash of that transaction. In a block we will not have a single transaction, we will have multiple transactions. Say this is a transaction 1, this is transaction 2, this is transaction 3, this is transaction 4, this is transaction 5, this is transaction 6. So this transaction will be passed to SHA-256 and will create a hash out of it. Same will happen with this one. Same will happen with this one. Same thing will happen with this one. Same thing will happen with this one and this one. After getting a hash, then these two hashes combined will be sent to SHA-256, and that SHA-256 will provide a single hash for both the hashes. Same thing happen with this one and these two and this two as well. Now these two hashes will be combined and sent to SHA-256 to generate a single hash. Then these two are left. Then these two will be sent to SHA-256 and they will create a single hash. So like if you can see, there are six transactions. Out of those six transactions, we have created a single hash, and this hash is known as Merkle root hash. why it is known as a Merkle root hash? It is generated out of you using Merkle tree. This whatever the tree that you are seeing in the data structure, this is a Merkle tree. Now let us see what is a block height. Block height is nothing but the digit, I mean the number of blocks. If you say this is this is the these are the blocks in our blockchain, and this is block number one, this is block number two, this is block number four, this is block number five, this is block number six. The block height of this block is 6. For the block height of this block is 5. Block height of this block is 4. Block height is nothing but it represents the length of that block, how many blocks are there. If you see, if you consider the block till here, it will be 4. If you consider till here, it will be 5. If you consider till here, it will be 6. So it is nothing but indexes of the blocks, like how many blocks are present in the blockchain. And the very first block in the blockchain is known as Genesis block. Genesis block. This was about the block header, and other is block body of the block. Body of the block consists of all the transactions which are happened in that which are stored in that block. So that's it for this video. For more such interesting topics, please follow our channel and stay connected with us. Thank you.